Hey there. In the last video, we have learnt about the basic organization of a computer system. The different parts were available in the computer system, and we studied about them all in a best possible way as we can. So in this chapter, we will know about the number system, as I have already told you. And in this number system, we will have many forms, and we will come to know about each and every one. Okay, we saw in the previous chapter that computer stores data internally in a format that human beings cannot read easily, isn't it? This is the reason why computer system requires IO, that's input output interfaces. Okay, every computer stores numbers, letters, and other special characters in a coded form. Before going into the detail of these codes, it is essential for us to have a basic understanding of number system. So hence, we will know the fundamentals of number system in this chapter. So first of all, number system has two types: non-positional and positional. Alright, so what is non-positional and what is positional? In early days, as we know, human beings counted on fingers. When counting beyond 10 fingers, they use stones, they use pebbles, sticks to indicate those values. This method of counting uses an additive approach, or we can say non-positional number system approach. In this system, we have symbols such as 1, this I symbol for 1, for 2, like for 3, and for 4, and so on. This was the case. Each symbol represents the same value regardless of its position in a number. Okay, and to find the value of a number, one has to count the number of symbols present in the number. Since it was very difficult, as we know, it was very difficult to perform the arithmetic with such a number system. Positional number systems were developed, and those positional number systems came into existence. And in those positional number system, there are only few symbols called digits. Okay, these symbols represent different values depending on the position they occupy in the number. Let us consider decimal number system over here. And why decimal number system? Because we use it in our day-to-day life. In this system, base is equal to 10. Base is always equal to 10 because there are altogether 10 symbols which are represented as 0, 1, 2, 3, 4, 5, 6, 7, 8, and 9, and those are the total 10 numbers. You know that in decimal number system, successive positions to the left of the decimal point represents units. How they represent the units? Like tens, hundreds, thousands, etc. Each position represents a specific power of the base 10. For example, let me take an example over here: 2586 with the base 10. This is the positional decimal number system. Okay, it consists of 6 in a unit place. Okay, it is in a unit place. 8 is at tens place. 5 is at thousands. Okay, sorry, tens, it's hundreds, and it's thousands. Okay, so it's a unit place, it's a tens place, it's a hundreds place, and it's a thousands place. Hence we can represent any number by using the available digits and arranging them in a various positions. This was the simple decimal number system. decimal number system, which is the one of the number system of the positional number system. Okay, let's talk about the binary number system. Okay, let's talk about the binary number system now. What is binary number system? In binary number system, the value of base is always 2. Okay, it's always 2, and computer understands the binary number system. Okay, it has only two symbols or digits, we can say 0 and 1. Only 0 and 1 can be used. The largest single digit is 1 and the smallest is 0. Each position in a binary number system represents a power of base 2. Okay, it's written in like this. Hence this system, the rightmost position in units position is always 2 raised to power 0, and the second position is 2 raised to power 1, and so on. Okay, I will make you understand this thing. So let me take an example here. If we have a binary 10101 with the base 2, we can understand it's a binary one. So what will be its decimal? So if we have to convert this binary number system into the decimal, and we have to know how much is this value in the decimal in the human readable form, so we have already known. Just write down 1 into 2 raised to power 0, as I said earlier. Then this 0, just put plus. Okay, this is the 1 unit, put plus, then this 0 into 2 raised to power, this time 1, plus 1 into 2 raised to power 2, plus 0 into 2 raised to power 3, plus 1 into 2 raised to power 1 is to 2 raised to power 4. Okay, so in this very fashion we have to write it. Let's solve it. This is 2 raised to power 4, it's 16, plus this is 2 raised to power 3, but it is multiplied with 0, that means the whole value will become 0, plus 2 2's are 4, plus this again there is a 0, so it will become 0, plus it is everything raised to power 0 is 1, that means it will become 1 at last. And if we add up, it is a 20 and 21 will be the answer. This 21 is in the base of 10, make sure, because it is a decimal form. So whenever we have to convert binary number system into the decimal number system, we have to follow this very procedure. Okay, this was all about the binary number system. One thing strikes in my mind right now. You might have heard about the bit. What is bit? Bit is either 1 or 0 in the computer language. If we say it is having a 1 bit of space, that means it is having a single, either it should be 1 or it should be 0. But what does bit actually mean? Bit means binary digit. Okay, it's called binary digit. Just make a note of this thing and remember it for your future uses. So whenever it strikes in your mind about the bit, so you should come to know about binary digit. Either it should be 1 or it should be 2. Now let me tell you about the octal number system. Octal number system. What is octal? From the name octal, that means it is going to have a base of 8. Okay, in octal number system the base is always 8, hence there are only 8 symbols or digits. So which are they? 0, 1, 2, 3, 4, 5, 6 and 7, and collectively they become 8. Okay, the largest single digit in here is 7 and smallest is 0. Each position in an octal number system represents a power of base 8. So now if we have an example, let's suppose 2057, it is an octal, and we have to know what is it is decimal. Okay, we have to find what is it is decimal with the base 10. Okay, we have to simply do the same thing, but here it was with the base 2, but in this case it will be the base 8. Simply we have to repeat the process. We have to come 7 into this number, 7 into 8 raised to power 0 plus it's 5 into 8 raised to power 1, then plus it will be 0 into 8 raised to power 2, and plus 2 into 8 raised to power 3. And if you solve it, this will become it will become no 1024. Yes, 1024 plus it will become 0 because it has a 0 in it. Then this will become 40, and this will become 7. Okay, everything raised power 1, everything raised power 0 is 1, into 7 is 7. Okay, it will be like this. Now this will be 7, 4, 13, 7, 0 and 1. Okay, this will be the equivalent of 2057 with the base 8 will be equal to 1071 with the base 10. This is the answer if we have to convert the octal number system into the decimal number system. Here we read about it. And lastly, let me tell you about the hexadecimal number system. It is also one of the important number systems in a computer science. Remember that in hexadecimal number system the base is always 16. Make sure the base is always 16, hence there are 16 symbols or digits present in it. The first 10 digits are same digits of a decimal number system, like 0, 1, 2, 3, 4, 5, 6, 7, 8 and 9, like the decimal number system. But the remaining 6 digits are the symbol like A, B, C, D, E and F, and we'll go up to the 15. Okay, in here A represents 10, B represents 11, this 12, this 13, this 14 and this 15. Okay, this representation respectively. Hence the largest single digit in the hexadecimal number system is F, which is 15. Okay, each position in the hexadecimal number system represents a power of base 16. Okay, now let's take an example again. If we have let's suppose 1AF is our hexadecimal number system, and we know it is always having a base of 16. So what will be its decimal number system? What will be its decimal? So we have to simply do the same thing, but here we had 8 as a base, here we had 2 as a base, but in this case we have 16 as a base. So what we will do, we will simply do the same thing, F into 16 raised to power 0 plus A into 16 raised to power 1 and plus 1 into 16 raised to power 2. Okay, now if we solve it, if we will solve it, it will become approximately 16 to 56 plus this will become 1, this is 10 and 160, this will become 15. Okay, because F is 15, so it will be equal to 431. This will be the decimal equivalent of this hexadecimal. So it was very simple concept of number system. I hope you have understood it. Let me show you the one more thing here. Let's suppose we have a binary of 101010 with the base 2. I will show you the conversion. So we have to know what will be its decimal number system, as we have already done it before. So we will repeat it once again. We will write down as 0 into 2 raised to power 0 plus 1 into 2 raised to power 1 plus 0 into 2 raised to power 2 plus 1 into 2 raised to power 3 plus 0 into 2 raised to power 4 and 1 into 2 raised to power 5. 2 raised to power 5. Okay, we will write it. It will be 32 plus 16 plus 8 plus, this will become 0 because it's 0, so this 0 plus 2 plus 0. Okay, so it will become 10 12 2 1 3 42. It will become 42 with the base 42. Now let's suppose we have 42 given, 42 with the base 10, and we have to find its binary one. So how we will do it? It has a simple method. We have to do the same thing like 42, we have to write it here, and then what we have to do is we have to simply divide it with 2. 2 2s are 2 1s are, okay, 2 1s are 2 and 2 2s are 4. So if we say there is no remainder is 0. Similarly, 2, it can't be divided by the 2, so 2 tens are 20. 1 is remainder, so we have to write down 1 over here. Now 2 5s are and 0 is remainder. 2 2s are and 1 is remainder. 2 1s are and 0 is remainder. Okay, 2 1s are and 0 is remainder. So just write down it in this fashion. So we will come to know 1 0 1 0 1 0. This is the same as this one with the base 2. That means 42 in the binary form, it is written like this. So this is the way how you are going to convert this decimal number system into your binary number system. In the coming video, we will focus on processors and memory. Okay, first we will try to cover processors, and after that we will see about the memory. I hope you will like, you will share, subscribe, and you will keep on watching my future videos. Till then, take care of your good self. Thank you.